Welcome, everyone. Today, we are diving into a crucial and rapidly evolving area of product development, AI product analytics. As AI becomes more deeply embedded in our products, the way we measure success must evolve too. This session is designed to be your comprehensive guide to understanding how to measure, track, and optimize AI-powered product features effectively. We'll explore the unique challenges and opportunities that come with AI analytics, and why traditional product metrics just aren't enough anymore. Whether you're a product manager, data scientist, engineer, or executive, this session will equip you with the frameworks and tools you need to make informed, data-driven decisions about your AI features. By the end of this presentation, you'll have a clear understanding of how to build a robust analytics strategy that not only tracks technical performance, but also captures user experience and business impact. Let's get started. Let's take a quick look at what we'll be covering in today's session. We've structured this presentation into 4 key chapters, each designed to build your understanding of AI product analytics step by step. First, we'll start with AI product metrics fundamentals. This section will help you understand the core metrics that truly matter when evaluating AI-powered features. We'll go beyond traditional analytics and explore the unique dimensions introduced by AI. Next, we'll move into tracking implementation. Here, we'll discuss how to properly instrument your AI features to capture meaningful data. You'll learn best practices for logging inputs, outputs, and user interactions in a way that's scalable and compliant. In Chapter 3, we'll dive into the performance measurement framework. This is where we'll explore how to evaluate and optimize AI models in production. We'll cover A/B testing, human feedback loops, and how to turn raw data into actionable insights. Finally, we'll wrap up with dashboard creation. You'll learn how to build analytics dashboards that are not only informative, but also tailored to different stakeholders, from product managers to engineers to data scientists. Each chapter is packed with practical guidance and real-world examples to help you elevate your AI product strategy. Let's jump into Chapter 1. And LT, Number and GT. Traditional product analytics have served us well for years. They focus on user actions and outcomes, things like click-through rates, conversion funnels, session duration, and feature adoption. These metrics are still important, but they only tell part of the story when it comes to AI-powered experiences. AI introduces entirely new dimensions that require a different approach to measurement. We are no longer just tracking what users do. We need to understand how the AI itself is performing. That means looking at model accuracy and confidence, inference latency, and how effective prompts are in generating useful responses. We also need to monitor hallucination rates, content relevance, and how human feedback is being incorporated. Without tracking these AI-specific metrics, we are essentially flying blind. We might know that users are clicking or converting, but we won't know if the AI is delivering value, making mistakes, or improving over time. To truly optimize AI features, we need to expand our analytics toolkit and start measuring what matters most in this new paradigm. Now we are entering Chapter 1, where we lay the foundation for effective AI product analytics. This chapter is all about understanding the fundamental metrics that define success for AI-powered features. Unlike traditional software, AI systems are probabilistic and dynamic. That means we need to think differently about how we measure performance. It's not just about whether a feature works, it's about how well the model performs, how users interact with it, and whether it delivers real value. We'll explore 3 core categories of AI metrics: technical performance, model quality, and user experience. Each of these plays a critical role in shaping the overall success of your AI product. And importantly, they must be balanced, because technical excellence alone doesn't guarantee a great user experience or business impact. Let's break down each of these categories in detail on the next slide. To build a successful AI product, you need to measure performance across 3 critical dimensions: technical performance, model quality, and user experience. Each category offers unique insights, and together they provide a holistic view of how your AI features are functioning in the real world. Let's start with technical performance. This includes metrics like inference latency, measured at different percentiles, throughput, error rates, and resource utilization such as GPU and memory consumption. You'll also want to track token usage and associated costs, especially if you're working with large language models. Next is model quality. This is where you evaluate how well your AI is performing in terms of accuracy, precision, and recall. Confidence scores help you understand how certain the model is about its outputs. You should also monitor hallucination frequency, compare outputs to ground truth data, and assess bias and fairness to ensure ethical performance. Finally, we have user experience. This is often the most overlooked, but arguably the most important category. Metrics here include interaction completion rates, time to first value, retry and refinement patterns, and satisfaction scores like CSAT and NPS deltas. These indicators tell you whether users are actually finding value in your AI features. Balancing all three categories is essential. A technically perfect model that users don't trust or enjoy using won't succeed. Likewise, a delightful experience built on a weak model won't scale. The key is to measure broadly and optimize intelligently. Now that we've covered the core categories of AI metrics, let's zoom in on how these apply to specific types of AI features. Not all AI is created equal, so your analytics strategy should reflect the unique behaviors and goals of each feature type. For AI chat and assistance, you'll want to track metrics like conversation length, question reformulation rate, and response usefulness ratings. These help you understand how well the assistant is guiding users and whether it's delivering helpful, relevant answers. You should also monitor follow-up question frequency and session task completion to gauge overall effectiveness. In content generation tools, key metrics include regeneration frequency, edit complexity, and how often generated content is actually used or implemented. You'll also want to assess generation quality scores and acceptance rates by content type. These indicators reveal whether the AI is producing valuable outputs or creating extra work for users. For AI search and recommendation systems, focus on result click-through rates, search refinement counts, and query complexity analysis. Time to relevant result is a critical metric here, along with diversity of results. These help you evaluate whether users are finding what they need quickly and efficiently. The takeaway is simple. Adapt your metrics to match your specific AI implementation. Don't rely on generic analytics. Focus on indicators that inform real product decisions and drive continuous improvement. While technical performance and user experience are essential, they are not the whole story. To truly understand the value of your AI features, you need to connect them to business outcomes. This is where AI analytics can drive strategic decisions and demonstrate return on investment. Start by measuring productivity gains. How much time are users saving? Are they completing tasks faster or producing higher quality outputs? These metrics help quantify the efficiency improvements AI brings to your product. Next, look at revenue impact. AI features can influence conversion rates, increase average order value, and improve customer retention. Tracking these changes helps you understand how AI contributes to top-line growth. Don't overlook cost reduction. AI can deflect support tickets, automate manual processes, and streamline operations. These efficiencies translate directly into savings and scalability. Finally, consider competitive differentiation. Are users choosing your product because of its AI capabilities? Are these features influencing purchase decisions or driving higher adoption compared to alternatives? By tying AI performance to business metrics, you elevate analytics from operational monitoring to strategic insight. This is how you make the case for continued investment in AI and ensure your features are delivering real value. In Chapter 2, where we shift our focus to the mechanics of tracking AI interactions. This is a foundational step in building a reliable analytics system for AI-powered features. Without proper instrumentation, even the most advanced models can't be evaluated effectively. AI interactions are more complex than traditional user actions. They involve dynamic inputs, probabilistic outputs, and nuanced user responses. That's why tracking needs to be intentional and comprehensive. We are not just logging clicks. We are capturing the full context of how users engage with AI and how the system responds. In this chapter, we'll cover best practices for instrumentation, including what data to collect, how to manage volume, and how to ensure compliance with privacy standards. You'll learn how to build tracking into your AI architecture from the start, rather than bolting it on later. This is where analytics becomes a strategic enabler. With the right tracking in place, you can uncover insights that drive product improvements, model tuning, and better user experiences. Let's dive into the details on the next slide. Instrumentation is the backbone of AI analytics. Without it, you can't measure performance, diagnose issues, or improve user experience. But tracking AI interactions requires more than just logging events. It demands a thoughtful, structured approach. Start by defining what to track. You'll need to capture the full input context, including the user's query, the system prompt, and any relevant background information. Record model parameters like temperature, top_k, and top_p, as these influence output behavior. Log the response details, full text, token usage, and generation time. And don't forget user interactions, regenerations, edits, acceptances, and ratings all provide valuable feedback. Finally, include session context to understand the user's journey before and after the AI interaction. Next, consider how to implement tracking. Manage data volume by sampling or summarizing responses. Scrub personal identifiable information to stay compliant with privacy regulations. Minimize latency impact by optimizing how and when you log data. Plan your storage strategy carefully, especially for large text fields. And above all, ensure your tracking meets legal and ethical standards. Instrumentation isn't just a technical task, it's a strategic investment. Build it into your AI architecture from the beginning, not as an afterthought. When done right, it unlocks the insights you need to make your AI features smarter, safer, and more impactful. To make sense of AI interactions at scale, you need a clear and consistent event taxonomy. This means defining and naming the key events that occur during AI usage so you can track, analyze, and optimize them effectively. Start with user-initiated events. These include actions like submitting an AI query, viewing the result, providing feedback, or sharing the output. These events reflect direct engagement and help you understand how users are interacting with your AI features. Next, define system events. These are triggered by the AI itself, such as when inference starts or completes, when an error occurs, or when the model switches. These events are essential for diagnosing performance issues and understanding system behavior. Finally, track outcome events. These tell you what happened as a result of the interaction, whether the content was applied, a suggestion was accepted, a task was completed, or the feature was abandoned. These are the most valuable signals for measuring success and identifying areas for improvement. Use a consistent naming convention that clearly distinguishes AI events from standard product analytics. This clarity will help your teams build better dashboards, run cleaner queries, and make smarter decisions based on the data. In Chapter 3, where we focus on how to measure and optimize the performance of AI features once they are live in production. This is where analytics becomes a powerful tool for continuous improvement. AI systems are dynamic. They evolve with data, user behavior, and model updates. That means performance measurement isn't a one-time task. It's an ongoing process that requires structured experimentation, thoughtful analysis, and a feedback loop that drives refinement. In this chapter, we'll explore how to run A/B tests tailored to AI, how to collect and act on human feedback, and how to interpret interaction patterns to uncover deeper insights. We'll also look at how to segment data, score responses, and evaluate long-term impact, not just short-term engagement. The goal here is to move beyond surface-level metrics and build a framework that helps you understand what's working, what's not, and why. With the right tools and mindset, you can turn raw data into actionable intelligence that improves both model performance and user satisfaction. Let's dive into A/B testing strategies on the next slide. A/B testing is a cornerstone of product optimization, and it's just as critical, if not more so, when working with AI features. But testing AI isn't as straightforward as testing a button color or layout. It comes with unique challenges that require a more nuanced approach. One of the biggest hurdles is model version control. You need to ensure that different versions of your AI model are properly tracked and isolated during testing. Then there's prompt variation. Even small changes in how you phrase a prompt can lead to dramatically different outputs. Personalization effects also complicate things, as AI responses may vary based on user history or context. And let's not forget interaction complexity. AI features often involve multi-step engagements that are harder to measure cleanly. To address these challenges, use targeted testing approaches. Run model versus model comparisons, experiment with different prompt engineering strategies, and test UX patterns that influence how users interact with AI. Sampling strategies can help manage variability and ensure statistical significance. When it comes to analysis, go beyond basic metrics. Score response quality, segment users to uncover behavioral patterns, and track long-term impact, not just immediate engagement. AI experiences can vary widely between users and sessions, so larger sample sizes and longer test durations are often necessary. The key is to focus your experiments on specific, measurable hypotheses. Don't ask vague questions like, "Is AI better?" Instead, test whether a new model improves task completion or whether a prompt tweak reduces hallucinations. Precision in testing leads to precision in product decisions. Human feedback is one of the most powerful tools for improving AI features. While automated metrics can tell you what happened, human input reveals why it happened and whether it was actually useful. But collecting feedback effectively requires a thoughtful strategy. Start by implementing a variety of feedback mechanisms. Use simple binary ratings like thumbs up or down for quick assessments. Add quality scales, such as 1 to 5 ratings, focused on specific dimensions like relevance, clarity, or usefulness. Include free-form text fields so users can explain their experience in their own words. And consider comparative ranking, where users choose between multiple AI outputs to indicate preference. The key is to balance feedback collection with user experience. Time your requests at natural interaction points, like after a task is completed or a response is viewed. Use sampling to avoid overwhelming users and explain how their feedback helps improve the product. Incentivize participation by showing that their input leads to real changes. Once feedback is collected, analyze it in context. Correlate it with model inputs and parameters to identify patterns. And most importantly, act on it. Close the loop by using feedback to refine prompts, retrain models, and improve UX. Human feedback isn't just a nice-to-have, it's essential for building AI that users trust and value. In Chapter 4, where we bring everything together into a visual, actionable format, AI analytics dashboards. Dashboards are the bridge between raw data and decision-making. They help teams monitor performance, identify issues, and align on priorities in real time. But building effective dashboards for AI features requires more than just plugging in metrics. You need to tailor your views to the needs of different stakeholders. Product managers, data scientists, and engineers all ask different questions, and your dashboards should reflect that. In this chapter, we'll explore how to organize dashboards by role, highlight the most critical metrics, and design interfaces that support deep analysis and fast action. Whether you're tracking model health, user satisfaction, or business impact, the goal is the same: make the data accessible, meaningful, and actionable. Let's take a closer look at how to structure these dashboards on the next slide. When it comes to AI analytics dashboards, one size does not fit all. Different stakeholders need different views, tailored to their roles and responsibilities. A well-organized dashboard strategy ensures that everyone, from product managers to engineers, can access the insights they need to make informed decisions. Start with the product management view. This dashboard should highlight feature adoption trends, user satisfaction metrics like CSAT and NPS, and business impact indicators such as conversion lift or retention changes. It should also surface key failure modes to help prioritize improvements and roadmap decisions. Next, build a machine learning and data science view. This should include detailed model performance metrics, input distribution analysis, failure classification, and A/B test results. It's also the place to track training signal collection and monitor how feedback is being used to refine models. Then, create an engineering view focused on system health. Include latency breakdowns, error rates and types, resource utilization, and cost per request. These metrics help ensure the infrastructure supporting your AI features is stable, efficient, and scalable. The key is to create role-specific views that answer the most important questions for each audience. And make sure each dashboard allows for drill-down analysis, so teams can quickly move from high-level trends to root cause investigation. Start simple. Build a minimal dashboard that covers the most critical metrics, then iterate based on the questions your stakeholders are asking most often. That's how you turn data into action.